Okay, so today's lesson is going to be properties of logarithms. Last lesson we learned what a logarithm is. It's just the inverse of an exponential. So what we're looking at today is specific properties of logarithms and different theorems that we're going to be working with. So let's go ahead and start with the two basic properties of logarithms. Part A says show that log base A of 1 equals 0. Well, all this means, it might not mean anything right now, but if we convert this to exponential form, which is what we did last lesson, this just means that our base A raised to the 0 power is equal to 1, which we know is true because anything raised to the 0 power is 1. 100 to the 0 power is 1. Negative 35 to the 0 power is 1. Anything to the 0 power is 1. And so we know that is always true, and that is why log base A of 1 is always going to equal 0. The second one, and A can be anything. The second part B, says show that log base A of A is equal to 1. Well, all this means, if I were to convert this to exponential form, this just means that our base A raised to the first power is equal to A, which we know is true because anything raised to the first power is just itself. So these are two basic properties, and we just summarize them right here. These are the formal textbook properties of what we've just kind of shown up above, but pretty much A raised to the 0 power is equal to 1. In other words, log base anything, A could be any number, of 1 is always going to equal 0. And log base A, where A could be anything of that same value A, is always going to equal 1. So just two basic properties that we'll start with. Just keep those in mind as we work on today's problems. All right, there are three other properties that we are going to cover today about logarithms, and the first one is called the sum of logarithms. Now, the sum of logarithms pretty much just means when you have log base A, and remember A could be anything, of two things that are multiplied by each other. So M is being multiplied by N. So if you have log base A of two things being multiplied by each other, they can be rewritten as a sum, meaning addition, of those two logs. And we'll do some examples in just a bit. But this just means you can take a single logarithm of two things that are being multiplied and break them apart into two logarithms being added together, and you'll get the same value. The second property is called the difference of logarithms property. So let's say you have logarithm base A, where A could be anything, of two things being divided by each other. Well, this property states that you can always rewrite this as two separate logarithms that are subtracting from each other. So log base A of the numerator subtracted log base A of the denominator. And these will give you the same value. So this is just another way to rewrite it using the difference of logarithms. And the last property that we're learning about today is called the power, the logarithms property. And it just means anytime you have log base A, where A could be anything, of something raised to a power, you can always rewrite that logarithm with the power as a coefficient. You can move that power to the front of the logarithm and still get the same resulting value. Okay, so three different properties. We're going to go ahead and do some examples and show what these three mean and how we can use them. Okay. All right, so example number 1. It says write each logarithm expression as a sum of logarithms. So example number 1A gives us a single logarithmic expression. It's just one single log, and it wants me to rewrite this as a sum of logarithms. So it pretty much wants me to break this apart, write it as two different logarithms that are being added together. Now, if you look at this example, we have log base 6 of x times y. We have two things that are being multiplied by each other. See, this big black dot means multiplication. And whenever two things are being multiplied by each other inside of a logarithm, you can use the sum of logs property, which is the first property I pointed up above. So we're going to go ahead and use this property, and what this means is I'm going to take this single logarithm and rewrite it as two different logs, which will be log base 6, the base doesn't change, of x, and you can put in parentheses or without, and then I'm going to add it to log base 6 of the other term that we multiplied by, which was y. And there we go. So we haven't changed the value. We've just rewritten it as two separate logs. And the reason why we're able to do that is the product equals the sum of logs property. And keep in mind that the base was 6. The base will still be 6 of each of these separate logs. So these equal each other. I just rewrote it as two separate logs being added. Okay. All right. Example 1, part B, we have log base 3 of 9x. Now there's no clear multiplication symbol like there was on the previous example, but we do still have two separate terms that are being multiplied by each other. 9x, these two terms are being multiplied by each other. It's not clearly written, but there is a multiplication symbol. 9 is being multiplied by x. So anytime you have two things that are being multiplied by each other inside of a logarithm, you can always rewrite it using the sum of logarithms property. And what that means is I'm just going to rewrite this as two separate logarithms, log base 3 of the first term, which is 9, plus log base 3 of the second term, which is x. Now you can leave it as is, and that's totally fine. This is right. We've already done that. We've rewritten that as two separate logs. I could simplify this actually a little bit further, only because I know what log base 3 of 9 is. Remember what this is asking us, it's asking 3 raised to what power is going to give us 9. And we know that that means 2. 3 raised to the second power is going to give us 9. So I could rewrite this as just 2 plus, and we don't know what log base 3 of x is. 3 raised to what power is going to give us that. We don't know what x is. We're not like solving for x or anything like that. So I would just rewrite it as log base 3 of x. And that would be our final answer. Again, the previous line isn't wrong. Technically, you've done what it asked. You rewrote it as a sum of logarithms, but you can simplify a little bit further because we know what log base 3 of 9 is. Okay. All right. All right, example number 2. This example says to rewrite each logarithm as a difference of logarithms. So we're probably going to be using the second property up here on top. So example number 2, part A, we are given log base A of x to the 4th power divided by y to the 3rd power. I'm going to go ahead and put some parentheses around here because all of this is inside the logarithm. Now we have log base A of two things that are being divided by each other. Fractions are division. So we have x to the 4th is being divided by y to the 3rd. Anytime you have two things being divided by each other inside of a logarithm, you can use the difference of logs property, which just states that anytime you have two things being divided by each other, you can rewrite it as two separate logarithms subtracting each other. The numerator subtract the denominator. So that's exactly what we're going to use. We're going to use this second property up on top to rewrite our problem as two separate logarithms. So example number 2, part A, I'm going to rewrite this as log base A, that doesn't change, of the numerator always goes first, subtract, then I'm going to write log base A of the denominator, which would be y to the 3rd. And we've rewritten it as a difference of logs. So we have done what the question asked. We wrote it as two separate logs subtracting each other using this property. We can actually go one step further only because I noticed that there is exponents. See how there's a exponent of 4 on the x, exponent of 3 on the y. When you have exponents, you can use the third property that we talked about up on top, which is called the power of a log property. And you can always replace the exponent by moving it to the front as a coefficient. So this answer isn't wrong, but using that third property, the power of a log property, I can always rewrite this as, I'm going to take this exponent 4, and I'm going to move it to the coefficient spot. So this becomes 4 times log base A of x. Subtract. Now y to the 3rd, that also has an exponent written on it. So I'm going to do the same thing. I'm going to take that exponent and I'm going to move it as a coefficient of the logarithm. And it'll become 3 times log base A of y. You can leave parentheses if you want to. It's up to you. And there we go. And this is our fully simplified form. So keep in mind that we didn't change the value of this. We don't even know what A, X, and Y are. But we rewrote it in a way that has 2 separate logarithms. And we used our properties to make sure that we did this correctly. All right, we're going to do the same thing for part B. For part B, we have log base 4 of 16 divided by 5x. We have 2 things that are being divided by each other inside of a logarithm. So I'm going to go ahead and use our second property up on top, which is the difference of a logarithm property. And it just says whenever you have 2 things being divided by each other, which that's what a fraction is, it's division, you can rewrite it as 2 logs subtracting each other. So this can be rewritten as log base 4 of the numerator, which is 16, subtract log base 4, notice that it's still the same base for each of the logarithms, base 4, because that's what it originally was, of the denominator, which is 5x. Now this answer is right. We can take it one step further just because I noticed that the first term, log base 4 of 16, is something that we can calculate. Log base 4 of 16, all that means is just asking us 4 raised to what power is going to give us 16. Well, if you know your powers of 4, 4 to the first power is 4, 4 to the second power is 16, and so on. So log base 4 of 16 is just 2, because this is just saying 4 to the second power is 16. So I'm going to go ahead and rewrite this as 2 minus, and I don't know what log base 4 of 5x is. We don't know what x is. We don't know that value. And so I can leave it as is. And this would be our fully simplified answer. All right, let's move on to the next page. All right, example number 3. So we're given a logarithmic expression, except this one's a natural logarithm. It's the same thing. If you don't like this notation ln, you can always rewrite the problem. If you wanted to rewrite it as log base e of this entire thing, x squared divided by x minus 1 to the third power, that's fine. It's the same exact thing as this ln. That just means natural log. But if you wanted to rewrite it just because that throws you off, that is fine. But this is a logarithm. This is a logarithm with base e. So all of the properties that I just mentioned apply and work the same way. So we can use any of these 3 properties or any of the first few properties as well to simplify this if we needed to. So what we're going to do is we're going to do the same thing, except it says, this one says write the expression as a sum or difference, depending on what type of problem is, and express all powers as factors. Now the first thing I notice on this problem is I see division. I have a big fraction, x squared is being divided by this entire denominator. So the first thing I'm going to do is I'm going to take care of that division by using the difference of logarithms property. So I'm going to go ahead and rewrite this problem as natural log, ln, of the numerator, which is x squared, subtract the natural log of the denominator, which is x minus 1 to the third power. Okay. All right, so I've done that. I also noticed that each of these natural logs have exponents on them. Anytime you have exponents, you can always use this third property. It's called the power of logarithm property. And what you can do is you can take that exponent and move it to the front of the natural log as a coefficient. And it'll give you the same value. So what we can rewrite this as is 2 times the natural log of just x minus, and then this exponent of 3, because it's the exponent of 3 is on everything x minus 1, we can move it to the front as a coefficient, 3 times the natural log of x minus 1. And that's it, and that's the most simplified we can make it. Okay. Now some people might be thinking, what about this x minus 1? Can we do anything with that? And the answer is no, we cannot, because there is nothing in our properties that said if you have 2 things subtracting from each other inside the logarithm, you can expand it. All we can expand is multiplication of 2 terms inside of a logarithm, division of 2 terms inside of a logarithm, or if there's any powers or exponents. and that is not the case. So that would be our final answer. Okay. And if you want to rewrite this with log base e's instead of ln's, that's also fine. All right, next example, number 4, we're just going to get some practice. So pretty much the previous 3 examples that we just did, we're going to go ahead and do a couple more examples to kind of help us get the gist of this. So example number 4, it gives us 2 logarithms, and this time we're rewriting it as a single logarithm. So I have 2 logarithms. I want to write it as just 1 logarithm. So we're working backwards now. Now it wants me to condense it. Instead of expanding my logarithms into separate ones, it wants me to condense it into a single logarithm if possible. So example number 4, part A, we have logarithm base A of 7 plus 4 times logarithm base A of 3. Now the first thing I notice is that these have the same base. They both have base A. They have to have the same base if we want to combine the logarithms, which they do. And I'll go ahead and write that. They have to have the same base in order to combine them using our properties. And in this case they do, and on all these problems I notice that they do, so I know we won't have a problem there. But we can't just combine any 2 random logarithms. The base is the same, base A, so I know I can combine them. Now the first thing I'm going to do, I know we see addition, but before I do that, I do notice that there is a coefficient, this 4. So I'm going to first take this 4 and I'm going to move it to become an exponent. Now what I'm using is this property, this third property, the power of logarithms property. So I'm going to rewrite my expression as log base A of 7, I'm not going to do anything with that yet, plus log base A of 3 raised to the 4th power. Okay. This third property tells me that I can do that, and it's not changing the value of anything. Now you can actually simplify that a little bit further. We already know what 3 to the 4th power is. That's 3 times 3 times 3 times 3, which is, I want to say 81. Yes, 81. So I can also rewrite this as log base A of 7 plus log base A of 81. It's not wrong if you leave it as 3 to the 4th, but we know that that's 81. All right, so I've taken care of that coefficient 4. The next thing that I would do is try to combine these 2 logarithms by using one of the properties. Now these 2 logarithms are being added together. They have the same base and they're being added together. So we will be using this property up on top, the sum of logarithms property, and we can combine them by, if we're working backwards, by multiplying m and n. So I'm going to rewrite this as a single logarithm, base A, and I'm going to have to take my 2 terms that are inside the logarithm, 7 and 81, and multiply them. 7 times 81. And that's not wrong, but we can simplify that a little bit further. We can actually do the math. What is 7 times 81? So log base A of, what is 7 times 81? That's 567. And you can put parentheses if you want. And that would be our most simplified answer. Okay. All right. All right, next one, part B, we have, once again, we have 2 separate logarithms. These are natural logarithms, but they work the same. They still have the same properties. You can rewrite these as log base e's if you don't like this notation, but it's the same thing. So I can use any of my properties on this problem as well. Now the first thing that you want to take care of is any coefficients. There is a coefficient of this 2/3. So I would want to get rid of that coefficient by making it an exponent. So my first step I'm going to do is rewrite this as natural log of 8, and I'm going to raise it to the 2/3 power. The entire coefficient became an exponent. Minus natural log of 5 squared minus 1. Those are just constants. We can actually calculate what is 5 squared minus 1. There's no unknown variables. 5 squared is 25. Minus 1 is 24. So this is just 24. Okay? And I can put parentheses around that too if you want. Alright, now the next thing, I've taken care of the coefficients. They have the same base. They're both just natural logs or log bases. The next thing that I can do, and I can actually figure out what is 8 to the 2/3 power. 8 raised to the 2/3 power is 4. So I can actually just rewrite it as natural log of 4 minus natural log of 24. And I have two natural logarithms. There's no exponents, there's no coefficients. I've already simplified everything because there's no x's. Everything is just constants. And I can actually now combine them using our second property, the difference of logarithms. We have two things that are being subtracted, two logarithms that are being subtracted. So we can combine them using division. Natural log of 4, which is the first term, divided by 24. Okay, and that's as simplified as it can get. I think it just wants me to rewrite it as a single logarithm. I can simplify 4 over 24 to be 1 over 6. Because if I take out a 4 from 4, I get 1. If I take out a 4 from 24, I get 6. And so this would be our single logarithm. You could technically actually evaluate that. What is natural log of 1/6? It didn't ask us to do that, but that's what you would get. I'll just leave it as is, because it just asked me to rewrite it as a single logarithm, which I've done. All right, and then last one, part C on this page, and then we'll move on. This one is pretty much a combination of all of the properties all together. This one kind of looks a little scary just because there's 4 different terms, but it's the same process that we've been using. Evaluate each of your 3 different properties wherever you can. So first thing I noticed is I notice that all 4 of these logarithms have the same base. And that tells us that we can use all these properties. If they don't have the same base, you can't use any of these. All of these have to have the same base, which they do, so we can actually use them, and so we can combine them in some way. I'm going to go ahead and just try to work with 2 logs at a time and then kind of combine them all as I go through. I noticed the first 2 logarithms are being added together. And so I'm going to use my property, the sum of logarithms property, which means if you have 2 logarithms that are being added together, they have the same base, you can always rewrite them as a single logarithm of the 2 terms being multiplied. So x times 9, which is just, 9 times x. And I've combined these 2 logarithms using our first property. I haven't done anything with the other expressions, so I'm just going to go ahead and rewrite those down, because I haven't done anything with them yet. Okay. All right. Once again, I'm going to do the same thing. I have these 2 logarithms, log base a of 9x plus log base a of x squared plus 1. These 2 logarithms are being added together. They have the same base, so I can combine them using that same property, the sum of logarithms. So I'm going to go ahead and do just that. I'm going to rewrite this as a single logarithm, base a, of 9x times x squared plus 1. Now I'm going to go ahead and rewrite that as 9x, and I'm going to multiply it times x squared plus 1. Okay, I haven't done anything with this separate log, so I'm just going to bring it down. Now the only thing here is just make sure that you multiply everything by everything, you distribute correctly. A lot of people would just multiply 9x times x squared, but you have to multiply 9x times x squared and also 9x times 1, because we are multiplying all of 9x times all of x squared plus 1. And once we do that, we should end up with log base a of 9x times x squared is 9x cubed. 9x times 1 is positive 9x. And I'm going to go just bring down this minus log base a of 5. Okay. All right, I've gotten it down to just 2 logarithms. We started with 4. Now I only have 2. And the only thing that I can do now is I have 2 different logarithms that are subtracting each other. They have the same base, base a. They're subtracting each other. So I'm going to use the difference of logarithms property. And I'm going to basically divide the 2 logarithms, whatever's inside the logarithms. So I will rewrite this as log base a of the first logarithm, which would be, let me use brackets, 9x cubed plus 9x divided by 5. And there's our single logarithm. Now, some of you might be wondering, what about this exponent 3? Can't you move it to the front, like our third property says? And the answer is no. This power of 3 is only on this single term. The power of 3 would have to be on the outside. It would have to be on every single thing, or on the entire term, which it's not, so you can't move it. But that's totally fine. We're going to leave it as is. All right, last page. This last part is a pretty useful formula. It's called the change of base formula. It is pretty important, and the reason why it's so useful, and a lot of students actually prefer this, is because you can actually use your calculator to calculate logarithms. Now, on the last lesson, remember I told you your calculator is only able to calculate, let me turn this on. If I type in log of, I don't know, anything, log of, I don't know, something, notice that there's no position to put the little base, because the only thing your calculator can calculate is base 10. So when I type this in, it automatically is log base 10. It's not written, but the base is 10. It's like saying 10 raised to what power is going to give us 2,000, which, I don't know, it's some crazy decimal. But the point of the matter is you can only calculate log base 10s on your calculator, which makes it kind of difficult when you have problems like this. Now, the cool thing about this, there is this change of base formula that you can use on logarithms, and it helps you use your calculator to actually figure out what is the actual value of this. So this change of base formula just means that you can always rewrite a logarithm as two different logs being divided by each other using base 10s. So what I mean by that might not make sense right now. For example, let's start with example 5. It says approximate what is log base 2 of 7. Now remember, what that's asking us, it's asking us 2 raised to what power is going to give us 7. And that's kind of hard to figure out, because there's not going to be like 2 to the first power is 2, 2 to the second power is 4, 2 to the third power is 8. So it never actually equals 7. It's got to be some decimal between 2 and 3. Now, it would be really hard to try to guess that decimal. It would take quite a while and quite some time. But instead of trying to guess, there is a way to calculate log base 2 of 7. And what we can do is, using this change of base formula, I can rewrite this as log base 10 of 7 divided by log base 10 of 2. I can rewrite it as that. If you're wondering, what about the base? Well, the base is 10. You can write the 10. Most people don't, but the base is 10 if you want to write the 10. And this will give you the same exact value. Now, this is actually something that we can use our calculators for. So I'm going to do just that. I'm going to use my fraction template. Alpha y equals enter. And on the numerator, I'm just going to type in log of 7. And on the denominator, log of 2. Now, you might be wondering, why doesn't it have the base 10s? Remember, it doesn't say base 10, but these calculators are automatically base 10s. And I can actually calculate what that is. And that is 2.8 approximately. 2.80. It says round to 4 decimal places. 807. And then the last one is a 35. So the 3 is going to round to a 4. And that would be our answer. Okay. So that just means that 2 raised to the 2.807354, I mean, you can write as many decimals as you want, to 2 power should give us about 7, which, again, we're rounding, so it won't give you exactly 7, but it's about 7. So that's what that means. Okay. So it's pretty useful. All right, and then last example, 2 more questions, same thing. We have log base 5 of 89. That's just asking us 5 raised to what power is going to give us 89. Well, I'm not sure what that is, because it's going to be some sort of decimal, because 5 to the first power is 5, 5 to the second power is 25, 5 to the third power, that's 5 times 5 times 5, that's 125. So it's somewhere between 2 and 3. I don't know what number that is, but instead of trying to figure that out by hand, we're just going to use our change of base formula. And we're going to take our problem and just rewrite it as log of 89 divided by log of 5. And remember, the base is 10 on these. That's what that means. You can write that 10 in, or you can leave it off. And I don't know what this is off the top of my head, but I can use my calculator for this. So I'm going to go ahead and type in log of 89 divided by log of 5, and I got 2.7889 approximately. So I got about 2.78894, so the 9 just stays as is. It doesn't round up. And there's our answer. And again, this just means that 5 raised to the 2.7889 power should be about 89, which if you want to see, let me see if it, no it doesn't. I'm trying to see if I can copy and paste that. 5 raised to the 2.7889 approximately. It should be about 89, which we're rounding, so it won't be exactly 89, but you get the point. Okay. All right, and then last one, part B. It's the same thing, just has some square roots, so it might throw you off a little bit. Log base square root of 2 of square root of 5. We have to figure out what this equals. Well, I can use my change of base formula and just rewrite it as log base 10 of the square root of 5 divided by log base 10 of the square root of 2. And I can figure out what that equals just by typing that in. Log base 10 of square root of 5 divided by log base 10 of square root of 2. There you go. And I got, that's how I typed it in, and I got about 2.3219. 2.3219, and it doesn't round up because the next digit is a 2. It says round to 4 decimal places. And there's our answer. Okay. All right, and that is it for properties of logarithms.